Imagine hiring a brilliant mathematician, like someone who just won a global gold medal in a competition against literally the smartest teenagers on the planet.
Right, a genuine prodigy.
Exactly.
Yeah.
So you bring them into your office, you sit them down, and you ask them what time it is. They stare at the analog clock on your wall, and they only get the answer right half the time.
Which is, basically a coin flip.
Right? You'd think they were playing a prank on you.
Okay.
But according to the massive new 2026 Stanford AI Index Report that just dropped, it's a 423-page beast, by the way, that is exactly the bizarre reality of artificial intelligence right now in April 2026. Welcome to the Deep Dive, everyone.
Yeah, thanks for having me. And that clock analogy is spot on. This report is, it's really the definitive empirical snapshot of AI development right now. It pulls all this data from McKinsey, GitHub, Epoch AI.
It covers everything, right? Technical progress, the economy, physical constraints.
Everything. But when you read between the lines of all those charts, a very clear and frankly very urgent narrative emerges for you, the listener.
Yeah, and that narrative is what Dr. Jonathan H. Westover has termed the asymmetric machine. Based on his analysis of the report, we are seeing this striking imbalance in 2026. On one hand, the technical capabilities of AI are just exploding.
Absolutely skyrocketing.
But on the other hand, our institutional readiness, our governance frameworks, and just equitable access to these tools, they are lagging dangerously behind.
Okay, let's unpack this. Why should we care about this asymmetry right now?
Well, you need to care because the technology is officially embedded. It's no longer emerging. The report documents that 88% of organizations now use AI in at least one function.
Wow, 88%.
Yeah, and 70% are deploying generative AI specifically. So the decisions that you and your organization make today about adopting this, they're going to dictate your competitive advantage and really your entire career trajectory for the next decade. If you're waiting for the dust to settle, the reality is you are already behind. But before we get into how this actually reshapes your specific workplace, we have to look at the technology itself, because we need to understand exactly what these models can and, honestly, bizarrely, what they cannot do right now.
Right, the capabilities.
Because the progress over the last 12 months is just staggering.
Yeah.
Take this benchmark called Osworld, and this isn't just a text test, It evaluates how well an AI agent can actually use a computer.
Like moving a mouse, clicking folders, that sort of thing.
Exactly. Navigating a web browser to complete a task. In just 1 year, the success rate for AI agents on Osworld jumped from 12% to 66%.
I mean, a 5-fold increase in 12 months is practically unheard of in traditional software development. It's monumental.
It's massive. And then there's SWE Bench. This tests software engineering. You basically give an AI a bug report from GitHub, and the AI has to locate the problem, write the patch, test it, and submit the code.
All autonomously.
Right. And models are now performing at near 100% of the human baseline on those tasks. And like I mentioned at the top of the show, Google's Gemini DeepThink just won a gold medal at the International Mathematical Olympiad.
Which is just wild to think about.
A machine just took home the gold against the most mathematically gifted human minds on Earth.
It is incredible, but, and this is crucial, it's also incredibly deceptive. This brings us to a concept researchers call the jagged frontier of AI capability.
The jagged frontier.
Yeah. You see, human intelligence generally scales in a predictable way. Like if you can do advanced calculus, we safely assume you know how to do basic addition.
Right. It's linear.
Exactly. If you can write complex software architecture, we assume you know how to format a basic Word document. But AI does not work that way at all. The frontier of its capabilities is extremely jagged.
Jagged is honestly the perfect word for it because the contradictions in the Stanford report are just wild. The exact same frontier AI models that can win an IMO gold medal can only read an analog clock correctly 50.1% of the time.
Which is wild.
It's a coin flip. For a task we literally teach to first graders. Or, look at the sciences. Models are outperforming human chemists on specialized benchmarks, but then they score below 20% on astrophysics replication tasks.
The drop-off is sudden and severe.
Yeah. And my personal favorite stat from the report, AI robots can succeed at 89.4% of manipulation tasks in a controlled digital simulation.
But then you put them in the real world.
Exactly. When you put them in an unstructured, real-world household environment, their success rate plummets to a miserable 12%.
Well, because a physical house is chaotic,
Yeah.
right? You've got sensor noise, variable lighting, a coffee cup left in an unexpected spot.
A dog running around.
Exactly. Things that completely derail a system that was perfectly competent in a neat little simulation.
I have to push back on the hype here, though. If I'm a manager listening to this sounds like a total nightmare to deploy.
What's incredibly difficult?
It's like building a 50-story skyscraper, but the contractors randomly forgot to build floors 7, 14, and 22. You can't just look at the beautiful penthouse and assume the foundation is solid.
That's a great way to put it.
So if performance doesn't map onto our human intuition of what is quote-unquote difficult, how can any organization confidently deploy this based on generic benchmark scores?
What's fascinating here is that this jagged frontier is not just some temporary bug that they're going to patch out next week. It is a fundamental feature of the underlying mechanics.
How so?
Well, AI learns via pattern recognition in its training data, right?
Yeah.
Not through generalizable reasoning. It doesn't actually, quote unquote, know what a clock is in the way that you or I do.
Right, it doesn't understand the concept of time.
Exactly. It just maps statistical probabilities of pixels or text tokens. So performance on one task is absolutely not a reliable predictor for performance on a slightly different task. You can't just look at a high benchmark score and assume it will handle your specific messy edge cases at work.
And that structural reality makes the global race for this technology even more interesting, especially when we look at the geopolitical data in the report.
The investment gap versus the capability gap.
Exactly. The capability gap between the top players is razor thin right now. Anthropic's leading U.S. model leads its closest Chinese competitor by a margin of only 2.7%.
2.7%. That is nothing.
But wait, how does that make sense? Because the U.S. invested $285.9 billion in private AI capital in 2025.
Right.
And China's reported private investment was only $12.4 billion. If the U.S. is outspending its competitor 23-1 in private capital, how is China keeping the performance gap to just 2.7%?
It's a really great question. And the index notes that while China's private investment looks tiny on paper, they have actually deployed an estimated $184 billion in government guidance funds since 2000.
Oh, okay, so the private number is just a fraction of the story.
Exactly. It heavily understates their true capital deployment.
Yeah.
But the larger point still stands. Raw technical capability is converging globally. You can't just buy your way to a dominant, uncatchable model anymore.
Because everyone knows how to build them now.
Right. The fundamental architecture is largely known.
So because these capabilities are converging globally and because they are so jagged, brilliant at structured coding but terrible at chaotic physical tasks, the economic and workforce impacts are landing in highly concentrated, unexpected ways.
They really are.
We aren't seeing the sci-fi movie scenario of just across-the-board mass unemployment for everyone. It's much more surgical than that.
Exactly. And to really understand the labor impact, we actually have to start with the economic upside. Because the upside is massive.
It is huge. The report estimates that generative AI created $172 billion in consumer surplus in the U.S. in early 2026 alone.
Which is a staggering number.
And for those who might not use that term every day, consumer surplus is basically the value we get without having to actually pay for it. Think about a small business using a free tier of a generative AI to draft marketing copy, analyze spreadsheets, write basic web code.
Stuff that used to cost thousands of dollars to outsource to a marketing agency.
Exactly. It's a massive injection of value that traditional GDP metrics struggle to even measure properly.
And this is the critical part, that massive surplus is masking a severe labor shock underneath.
It is, and this is the stat that should really terrify young professionals. U.S. software developers aged 22 to 25 saw their employment drop nearly 20% in the last year.
20%? Just think about that.
Yeah, let me repeat that for the listener.
Okay.
A 20% drop for entry-level developers. Meanwhile, the headcount for older, more senior developers actually grew.
Right.
And looking ahead, 1/3 of surveyed organizations expect workforce reductions next year. And those are heavily concentrated in software engineering, supply chain, and service operations.
If we connect this to the bigger picture, AI isn't causing a broad recession. It's causing a profound structural shift. It is wiping out the entry-level rungs of the corporate ladder.
Right, the junior roles.
Yeah, think about what a junior developer actually does. Highly structured, measurable, repeatable code generation. Those are the exact tasks sitting perfectly on the capable side of AI's jagged frontier.
They don't require the messy real-world reasoning.
Exactly. The very tasks we usually give to recent grads to help them learn the ropes Those are the ones being automated away.
Which creates an incredible paradox when we look at global adoption, because the U.S. is the undisputed leader in building the AI, right? And U.S. workers are feeling this structural shift the hardest.
Right.
Yet, the U.S. ranks 24th globally in population adoption. Only 28.3% of the U.S. population is actively using it.
That is shockingly low.
It really is. Meanwhile, Singapore is at 61%, the UAE is at 54%, and on top of that, there's been an 89% drop since 2017 in AI researchers moving to the U.S.
And most of that drop was recent, wasn't it?
Yes. 80% of that drop happened just in the last year alone.
The skills to build the technology are no longer consolidating in one place. And maybe more importantly, the skills to actually use the technology are accelerating way faster outside the U.S.
It's like we spent hundreds of billions of dollars inventing and building a fleet of the world's most advanced supersonic jets. But countries like the UAE and Singapore are the ones actually putting their citizens in the simulators and training pilots.
That is a perfect analogy.
Aren't we setting ourselves up for a massive geographic skill deficit in 5 years?
You
I mean, who cares if you own the factory if nobody in your country actually knows how to fly the plane?
It is a profound vulnerability, and it highlights exactly what Dr. Westover means by the asymmetric machine. We have hyper-focused on capability development at the expense of widespread adoption readiness.
And workforce transition, too.
Exactly.
Well, here's where it gets really interesting. Because as companies scramble to replace those junior workers and capture that massive $172 billion surplus, they are running blindly into brick walls.
Massive ones.
And those walls are both digital and intensely physical. Let's talk about the digital risks first. The 2026 index shows that foundation model transparency actually declined in 2025.
Which goes against everything we were promised a few years ago.
Right. The companies building these models are becoming more secretive about their training data and their safety testing. And consequently, reported AI incidents hit 362 last year, which is a 55% jump from the prior year.
And managing those risks is, it's mathematically complex. There's this paradox in responsible AI. Improving one safety dimension often mathematically degrades another.
Wait, really? How does that work?
Well, if you heavily lock down a model with strict safety guardrails so it refuses to answer sensitive questions, you often reduce its overall accuracy on harmless, complex tasks.
Oh, because it gets overly cautious.
Right. Or, alternatively, if you obfuscate training data to protect user privacy, you remove the demographic markers that are necessary to test the model for bias.
Ah, so you protect privacy but degrade fairness.
Exactly.
Yeah.
Essentially degrading its fairness. And there's no standardized framework in the industry to handle these trade-offs right now.
But it's not just the digital math. The physical risks are honestly terrifying. We have this massive global trillion-dollar software boom, and the entire physical supply chain rests on a single choke point.
TSMC.
Yes, the TSMC foundries. And we aren't just talking about a big factory. TSMC is one of the only places on the planet that has mastered extreme ultraviolet lithography.
EUV, right?
Right, EUV. It's the ability to etch microscopic circuits onto silicon wafers at the scale needed for these super advanced AI chips. And they are located in one of the most highly contested geopolitical territories on Earth.
It is the ultimate bottleneck. I mean, a disruption there wouldn't just slow things down a bit. It would freeze global AI infrastructure development practically overnight.
Because you can't just build a new factory.
Exactly. You cannot spin up a cutting-edge fab anywhere else without years and years of lead time.
And even if the chips keep flowing perfectly, the infrastructure itself is devouring the planet's resources. AI data centers now consume 29.6 gigawatts of power.
That number is hard to even wrap your head around.
To put that in perspective for the listener, that is comparable to the peak energy demand of the entire state of New York.
Just for data centers.
Just for AI data centers.
Yeah.
And the emissions just training Grok 4 emitted 72,816 tons of CO2. And the water. The annual inference water use for GPT-4 alone could exceed the drinking water needs of 12 million people.
Which surprises a lot of people when they hear it.
Right, because we constantly talk about AI like it's this ethereal, magical thing living up in the quote-unquote cloud.
Right, it sounds so clean.
But a data center is not a cloud. It is a massive physical warehouse filled with thousands of GPUs running incredibly hot. Generating a single complex AI response requires vastly more compute power than a traditional Google search.
Orders of magnitude more.
Exactly, which means those servers need massive cooling towers, evaporating literally millions of gallons of water just to keep from melting. Are we going to hit a hard physical wall where we literally run out of water or grid capacity before we ever reach artificial general intelligence?
This raises an important question. Honestly, maybe the most important question of the whole report. With jagged, unpredictable capabilities, structural shifts, wiping out entry-level jobs, declining transparency, and massive physical bottlenecks. How does an organization, or how do you as an individual listener, actually survive and thrive in 2026?
Yeah, what's the playbook?
The answer in the data is very clear. The organizations that are winning are treating responsible AI not as a compliance chore, but as competitive infrastructure. The winners are moving deliberately.
And the report gives us some incredible case studies of what that deliberate movement actually looks like, because essentially what we are seeing is a massive corporate rebellion against Silicon Valley's oldest religion.
Move fast and break things.
Exactly. You can't move fast and break things when a hallucination could shatter your entire global logistics network. So let's look at Salesforce. Instead of hiding their AI deployment or, quietly automating roles behind the scenes, they handed AI tools to all their employees early on for open experimentation. Total transparency.
And what did that do?
Well, the result was it drastically reduced worker anxiety and actually helped the company find unexpected efficiency use cases they hadn't even thought of.
Because they understood that uncertainty causes more workforce panic than the actual automation itself.
Exactly.
Then you have companies like Accenture and AT&T who modeled something called procedural justice.
Procedural justice.
Yeah, procedural justice is about the perceived fairness of the process, not just the final outcome. So Accenture committed to no net workforce reductions. If a structured, junior-level task was automated, they aggressively reskilled that specific worker for a higher-level analytical role.
And AT&T took a slightly different approach, right? Because they actually had to make cuts. But they provided 12 months of healthcare continuation and tenure-based severance.
Right.
By handling the transition with transparent procedural justice, they maintained incredibly high morale and trust among the employees who actually stayed.
Exactly. And when it comes to the actual skills, look at what Siemens did. They didn't just throw some generic 1-hour what is AI webinars at their staff and call it a day.
Right, checking the box.
Yeah, they created an internal AI campus. They built modular, role-specific training programs and tied them directly to career progression.
So it actually mattered for their jobs.
Exactly. You want a promotion. You complete the AI module tailored specifically to your engineering or operations role. It aligned the upskilling directly with their actual operational needs.
And then there is the governance piece, which is where JPMorgan Chase and Unilever are setting the standard. JPMC created a centralized AI governance office that reviews all high-stakes use cases.
Right.
And Unilever took it a step further by embedding cross-functional teams directly into their supply chain AI projects. They didn't just have tech guys building the models. They put supply chain experts, risk managers, and ethics officers in the room together.
From day one.
Yes. And in both cases, these governance layers intentionally slowed down the initial deployment of the technology.
Which sounds completely counterintuitive in a tech race, but they did it to prevent disaster down the line.
Right. I want to synthesize this because it's a huge shift. Every single success story from the report involves a company intentionally slamming on the brakes.
Yep.
They are pausing to build guardrails, to create cross-functional teams, to build humane severance packages, and even Google, which is at the absolute forefront of technical capability, is actively slowing down parts of its infrastructure rollout.
They have to.
They are diversifying their data centers and tracking energy and water use, not just as a PR sustainability metric, for a press release, but as a hard operational risk. They are actively planning for grid limits. Moving deliberately really is the new moving fast.
It absolutely is. I mean, you can build the most advanced supersonic jet in the world, but if you don't have air traffic control, trained pilots, and enough jet fuel, you are going to crash.
So what does this all mean? We've covered a 423-page mountain of data, staggering capability jumps, the hollowing out of entry-level jobs, and the physical limits of the power grid. Bring it home for us.
The final synthesis of the 2026 Stanford AI Index is really this. Raw technical capability is completely commoditized. It is converging globally. In the very near future, you will not have a competitive advantage just because you bought access to the smartest, fastest AI model.
Because everyone will have that access.
Everyone. In the next phase of the economy, your advantage will come entirely from your institutional capacity to deploy that model responsibly, equitably, and sustainably. It is about governance. It's about reskilling your workforce and managing your physical constraints. The asymmetric machine can only be balanced by institutional readiness.
That is a very powerful takeaway. But before we go, I want to leave you, the listener, with a final, slightly provocative thought to mull over. We talked a lot today about how massive organizations are managing their readiness, but what about you?
As an individual.
Right. The report briefly mentions a concept that really stuck with me. They note that heavy AI reliance might carry a long-term learning penalty.
Oh, that's interesting.
Yeah. If you are using generative AI every single day to write your base code, to draft your project outlines, or to clean your data, are you building your own deferred productivity costs?
You're shipping the fundamentals.
Exactly. Think about it. If those entry-level, highly structured tasks are how we actually learn the deep architecture of our professions, and you are offloading all of that foundational thinking to a machine, are you, just like the companies we discussed, letting your own personal readiness lag behind?
A personal asymmetry.
Yes. Are you smoothing out your own jagged frontier, or are you just letting the AI do the heavy lifting while your fundamental skills atrophy? It is something to really think about the next time you're tempted to just hit generate. Thanks for joining us on this deep dive.